Good morning, everyone. Today we will be doing Unit 7, Lesson 1, Area of 2D Shapes. So hopefully nothing from today will be new. It should all kind of be a review from things you've done with geometry in the past. So we're going to start by looking at some conversions and converting between the imperial system and the metric system. So the imperial system is a collection of units that includes inches, feet, and miles for lengths. All right, and then for volume, we have cups, quarts, and gallons for volume. And then finally, we have ounces and pounds for weight. Right, so we're familiar with those units, but in Canada we use the metric system. So it was a system introduced in Canada in the 1970s to replace the imperial system. And one of the reasons that we use the metric system is because it's a base 10 system, meaning as you're converting from one unit to another in the metric system, it's all multiplied or divided by 10. So conversions can be made between these two systems, between the imperial and metric system. And this chart here is all your conversions, which you do not need to memorize. Any assessment you have in this course and in most math courses, you'll be provided those conversions, because in the real world, nobody has these memorized. Maybe a few of them if they use them every day. But if you're converting, generally you're going to look up what's the conversion factor and then calculate it according to that. Okay, so on the left side of the chart here, we have going from imperial to metric equivalents. All right, and I just want to point out that if we're going from imperial to metric, if we're saying 1 inch, 1 inch equals 2.54 centimeters, that means we're taking our inches and we're multiplying by 2.54. All right, the same is true if you look at all of these. So if we have 1 foot, we're trying to get to meters, we're going to multiply by 0.305. On the other side here, we have metric to imperial equivalents. So in this case, again, we're going to multiply, but you should notice that we're going the other way. So to go from centimeters to inches, we're going to multiply by 0.39. So however many centimeters we'd have, we've multiplied by 0.39. To go from meters to inches, or more common actually, is to go from meters to feet. You're going to take however many meters you have and multiply by 3.3. All right, and so on. So we're going to look at some of these conversions now and see if we can calculate them. So first, convert the following measurements. We have a pencil that's 7 inches long, and we need to convert it to millimeters. So we're going to go from inches to millimeters. Well, if I look up on my chart, I have inches to centimeters, right? But I don't have to millimeters. So I'm going to start by using the inches to centimeters. I'll do that for step 1. So let's say step 1, we will go from inches to centimeters. All right, and we know that 1 inch equals 2.54 centimeters. So if we're going to convert it, we're going to take the fact that we have 7 inches and we're going to multiply by 2.54, and that's going to equal 17.78 centimeters. Okay, that's step 1 though. We got to get to millimeters. So hopefully we can remember how many millimeters are in a centimeter. Okay, there's 10 millimeters in a centimeter. So 1 centimeter equals 10 millimeters. So we just repeat that process. We're going to take the number of centimeters we have and we'll multiply it by 10, and that equals 177.8 millimeters. Okay, let's take a look at another one. So we have a string of Christmas lights, 12.5 feet long, and we are converting this to centimeters. Okay, we are going from feet to centimeters. So if I'm looking for feet, I'm going to look on my imperial side still. All right, and we're we don't have feet to centimeters, but we do have feet to meters. So maybe we can start with feet to meters and then go to centimeters from there, just like we did in the other one. So a little bit of a two-step process here. So let's first go from feet to meters, and we know 1 foot equals 0.305 meters. So we're gonna multiply by that 0.305. So if we have 12.5 feet, we're gonna multiply by 0.305, and that's gonna equal 3.1825 meters. And then step 2 would be, okay, well now we gotta go from meters to centimeters. So 1 meter equals 100 centimeters, right? Because I forgot my C on there. Centi is short for a century or 100. So 1 meters equals 100 centimeters. So we're gonna take our meters we have here, 3.1825, and just multiply by 100. And you should get 381.25 centimeters. Okay, this next one I want to talk about because it looks a little different. On this next example, we have 12 meters squared. All right, so 12 meters square of wallboard converted to square feet. So we're going from meters squared to square feet. And if we wanted to represent that as an abbreviation, right, we would say feet squared. So whenever we have something squared, that just means we're going to do the conversion 2 times. So what I mean by that is in this case, we need to go from meters to feet, right? So 1 meter equals 3.3 feet, right? If we look from our metric to imperial conversion, we can see that 1 meter equals 3.3 feet. All right, so we're going to multiply by 3.3. So if I have 12 meters, I'm going to multiply by 3.3, but I'm going to do it 2 times. That's what that squared unit means there. So if I multiply that 2 times, I'm going to get 130.68. And again, that'll be feet squared because I did that conversion 2 times. All right, let's switch gears a little bit and look at some area stuff. So we're looking at composite shapes for this note. So to calculate the area of an object, all measures must be in the same units. And for composite figures, we're going to add the area of the component figures. So we'll look at an example here, and that'll be it for your notes for today. So the Norman window in the hallway of a house is in the shape of a rectangle with a semicircle on top. So the rectangular portion has width 5 feet and height 8 feet. So it says determine the total area of the glass in the window to the nearest tenth of a square foot. So we have 2 shapes here we're dealing with. We're going to deal with this semicircle, right? We got to find the area of that. And then we also have to find the area of this rectangle. Okay, so let's label some of the things we know here. So first of all, if we have 5 feet at the base of our rectangle, we would assume that this is also 5 feet, which will help us with our circle. So let's do the area of our semicircle. We'll do it in blue. So area of semicircle. Okay, so if we know the area of a circle, hopefully remember that the area of a circle is just pi r squared, but this is half of a circle, so we're going to divide it in half. Okay, so divide circle in half. Okay, so if we were to calculate that, we need to determine what's our radius. Well, if 5 is our diameter, then radius is just going to equal half of that, right? Our radius is half of our diameter, so our radius is going to be 2.5. So we're going to have pi times 2.5 squared divided by 2, and that's going to equal 981.7 feet squared. Okay, and then if we needed to calculate the rectangle, let's do the area of the rectangle. Hopefully we all remember that the area of a rectangle is just length times width. So that'd be 5 times 8, or 40 feet squared. So finally, if we wanted to do our total, okay, our total is just going to equal our rectangle plus our semicircle. Okay, so our rectangle was 40 and our semicircle was 981.7. So we're going to have 1021.7 feet squared. So we can say, therefore, the total area of the glass is 1021.7 feet squared. Okay, last question for today. We're going to take a look at the perimeter now of this window. So we have to remember how to find the perimeter of a circle and of a rectangle. So the perimeter is the circumference of a circle. Okay, that's the math term we use for perimeter of a circle. So the perimeter of a circle is represented by 2 pi r, but again, we have to divide that in half because we're only doing half of a circle. So we'll plug in again those same values. Our radius is 2.5. And if we were to calculate that, we should get 7.9 feet. Remember, this is perimeter, it's not area, so we're dealing with just feet, not feet squared. And then if we look at the perimeter of the rectangle, okay, the perimeter of our rectangle is going to be 2 of our lengths plus 2 of our widths. So my length is 5 and my width is 8. So you'll have 10 plus 16 or 26 feet. So just like above, our total is going to equal the perimeter of our semicircle plus the perimeter of our rectangle. Okay, so the total is going to be 7.9 plus 26, which is 33.9 feet. So therefore, the perimeter of the window is 33.9 feet. Okay, that is it for your notes for today.